When we talk about probability, we're talking about the result of a random process. That is to say, a process whose outcomes are random. When you shuffle a deck of cards and draw one, you might get an ace or you might not. There's no reason to think that you'll get the ace, but there's no reason to think that you won't get the ace either. It's just luck. That's essentially what we mean by random. A random process has these outcomes and nothing is determining whether they occur other than chance. We'll usually make reference to random variables, which the textbook defines as random processes with numerical outcomes. There are two dominant interpretations of probability, Bayesian and frequentist. The main difference is that frequentists believe in an objective probability that's out there governing how often random outcomes occur. To a Bayesian, probability is a measure of your own uncertainty regarding an outcome, taking into account your knowledge of the situation. In this framework, probability is a subjective belief. Here I give an example of how they approach the topic differently. In the case of a coin flip, it's generally accepted that the probability of heads is 1/2. To a frequentist, that means that if you continue to flip the coin forever, the proportion of heads will tend towards 1/2, and this is just an immutable fact of life. To a Bayesian, probability all boils down to how likely you think an event is to occur. If a Bayesian thinks that a coin has a 1/2 probability of occurring, it simply means that they're betting that the event is just as likely to occur as not occur, and this probability can change if there's new information. A Bayesian might decide that the coin has probability 1/2 of coming up heads. If you then flip the coin 100 times and only get 20 heads, the Bayesian might then decide that the probability of heads is closer to 20%, and they'll continue to think that way until they see new evidence. To the frequentist, on the other hand, the probability is either 1/2 or it's not. It's an objective fact that you can't change. A frequentist might hypothesize that the probability of heads is 1/2. You flip the coin 100 times, get 20 heads. The frequentist might then decide that their hypothesis was wrong and that the probability wasn't 1/2. They can change their estimate of the probability, but they don't presume to know what the true probability is. A Bayesian basically always knows what the probability is because it's their own belief. In this class, we'll stick with the frequentist version of probability. As I said before, in frequentism, probability means that if you repeat a process an infinite number of times, the proportion of times that an event occurs tends to some number between 0 and 1, and that number is the probability of the event's occurrence. This is called an asymptotic result. Let me remind you of what an asymptote is. Hopefully you've seen a graph of a function like f of x equals e to the negative x before. Looks kind of like this. When x is negative, e to the negative x is big. When x equals 0, e to the negative x equals 1, and it continues to get smaller and smaller as x gets bigger. As x goes to infinity, e to the negative x approaches 0. It never hits 0, but it gets closer and closer. 0 is called an asymptote. In probability, as the number of times we repeat the process increases, the proportion of times an event occurs approaches the probability. There's an illustration of this on page 82 of the book where they draw a graph that looks kind of like this. About a simulated die. The proportion of rolls that equal 1 kind of bounce around 1/6 fairly widely at first, but as the number of rolls increases, the proportion continues to get closer to 1/6. Now let's look at some properties of probability. All throughout the discussion, we'll be using this P of A notation. This means the probability that the event A occurs. A probability is always a number between 0 and 1. An event with probability 0 is impossible. Something that has probability 1 is certain to happen. The set of events where A doesn't happen is called the complement of A, and we denote that as A complement. Note that there is probability 1 that either A happens or A complement happens, because something has to happen and it can't be both. Thus, the probability of A complement equals 1 minus the probability of A. If you're drawing a card from a deck and A is the event that you get an ace, then the probability of A is 4 divided by 52, which is 1 divided by 13, because there are 4 aces and 52 cards. A complement would be the probability that you don't get an ace. It equals 1 minus the probability of A, which is 48 divided by 52, or 12/13, because there are 48 cards that are not aces. You have a 48 divided by 52 probability of drawing one of those. We use the language of set theory to represent probabilities, so we can represent events with Venn diagrams, as you see below. Events are disjoint when they can't both happen. Complementary events are disjoint. We write P, A, and B for the probability that both A and B occur, and P, A, or B for the probability that either A or B or both occur. Let X be the number that comes up when you roll a die. X is a random variable because it's the result of a random process. We're interested in the events X equals 1 and X is even. The probability that X equals 1 or X is even is the probability that X falls into the set 1, 2, 4, 6. For a die roll, there are 6 outcomes, all of them with probability 1, 6. The probability of rolling one of these 4 numbers is 4, 6, or 2/3. The probability that X equals 1 and X is even is 0 because a number can't be both 1 and even. That's an impossible event. Here's an example with colored shapes. There are 8 shapes here. If you randomly choose one, the probability of getting an orange shape is 5/8, and the probability of getting a green shape is 3/8. The event of getting an orange shape is the complement of the event of getting a green shape, because the probability of orange equals 1 minus the probability of green, and vice versa. Circle and square are not complementary because the probability of drawing a circle is not 1 minus the probability of drawing a square. You can't get a shape that's both a circle and a square, so circle and square are disjoint events that are not complementary. The probability of getting something that's both green and a circle is 2 divided by 8, which is 1/4. The probability of getting something that's either green or a circle is 5 divided by 8. When we're dealing with the probabilities of 2 or more events, we have to be careful about how we add them together. There's a rule that says the probability of A or B equals the probability of A plus the probability of B minus the probability of both A and B. I'll show you where this comes from with Venn diagrams. Begin with 2 events. To get the probability of A or B, find the probability of A, add the probability of B. But notice you've counted the probability of A and B twice. You have to subtract one of them. And that's where this rule comes from. Try not to confuse events with the probabilities of those events. You can't perform arithmetic on events. You can perform arithmetic on probabilities because probabilities are always numbers between 0 and 1. An event is technically a set. You can add two probabilities together, but it doesn't make sense to add two sets together. If you want to combine sets, you need to use these operators and or. There is a concept of subtracting sets, A minus B, sometimes it's written like this. It means the portion of A that's not in B. But that's not something we're going to deal with in this class. Some examples with a die. Here we have that the probability of A is 1/2, the probability of B is 2/3, and the probability of A and B is 1/3. And you can see how it all fits together in this general addition rule down here, so that the probability of A or B is 5/6. Back to the shapes. You can see that the probability of orange or square is 6/8 or 3/4, and that is 5/8 plus 3/8 minus 2/8. The probability of green or triangle is 4/8 or 1/2, and you can see that that is 3/8 plus 1/8 minus the probability of a green triangle, which is 0. And you can see that when events are disjoint, the probability of both occurring is 0, so this part drops out, and our rule reduces to the probability of A or B equals the probability of A plus the probability of B.